Welcome, everyone. Thank you for coming to this talk on Android accessibility and the second day of I/O. Hope you had a great party last night and are ready for a whole sequence of talks this morning. My name is Raman. I've been working on Android and Chrome accessibility for the last few years. And with me, I have Casey Burkhardt and Alan Viverette, who also work on Android accessibility. A quick intro to what we are going to be talking about. So this is about Android accessibility, and we've built this as an advanced developer talk. Android accessibility is a core part of the Android framework. And the way you should think of what that core capability, the framework, does is think of it as mechanisms that are built into the platform so that you as a developer can reach the largest number of users. You heard some fairly amazing numbers at the keynote yesterday. I can never remember the numbers. I think it was about 900 million Android devices out there now. By the time we are done doing this talk, it's probably 902 million at the rate at which things grow. What is Android as a platform giving you, the developer? It's giving you, the developer, the ability to write these wonderfully innovative apps that run on a very large variety of devices. So you don't have to worry about different screen sizes, 5 inches versus 4.5 inches versus 5.5 inches. You don't have to worry about does this phone have a keyboard or not, all of those things. Think of the other half of the equation, the people who use your applications. Today, most of you are probably targeting your applications at users who have perfect vision, who have perfect hand-eye coordination, who can use the touch screen well. In a sense, you are not having to focus as much on the user's abilities. What we, from the accessibility side of Android, do is to make sure that you can continue to focus on your app, on the core part of your app. And the Android platform just does the heavy lifting for you in terms of making sure that your app just works for all your users. But life's never that simple, right? If you had to code your app all the way from the beginning to worry about the blind user, the low vision user, the deaf user, the motion impaired user, you would have a very hard time. Our goal is to make that really, really easy. And the core platform APIs, everything we talk about today will be in the context of low vision and blindness. But the way it is architected, when you address these use cases, you actually will be covering a lot more use cases, all the way from one-button controls for somebody who's severely motion impaired to the blind user who cannot see at all. We've done previous talks about the core accessibility layer in Android, and I highly recommend our talk from last year, which gave a very detailed overview of the features in Jelly Bean. This year, what we will do is Casey will first take you quickly through some of the accessibility basics as a quick revision, and then Alan will go through in detail about the next level, which is what if you're designing an entirely custom UI. As I said, the Android platform with its built-in accessibility, with its built-in view layer, has accessibility support for all the widgets. But what if you've decided to create a completely new experience? How do you easily make that then accessible? So that will be the second half of this talk. We will have office hours. We will give you details on the office hours again towards the end of the talk. We also have a sandbox downstairs where you can see accessibility technologies both from us at Google as well as from our partners. So enjoy the talk. I look forward to your questions at the end. And take it away, Casey.
Great. Thanks, Raman. Hi, everyone. I'm Casey Burkhardt. I'm a software engineer on the accessibility engineering team at Google. And as Raman mentioned, I'm going to go through some of the accessibility basics on Android. So accessibility is exposed through accessibility services. The framework provides information about user interaction to these services through objects called accessibility events. These are presented to accessibility services which have a privilege level that's a bit higher than other services to receive information about this user interaction. So we get information about notification, movement of focus, how the user interacts with apps, and the accessibility service is responsible for providing feedback for that. We ship 2 accessibility services right now. The first is TalkBack, which is a screen reader that's optimized for the touch screen. what we do is we allow for different types of navigation throughout your application and throughout Android. We allow random access through a feature called Explore by Touch, which allows a user to use a single finger to interrogate the screen and explore what they're currently touching. The accessibility service gets information about that interaction and provides feedback to the user. We also provide access to this on-screen content linearly. So if a user is unfamiliar with an interface, they can navigate it item by item to see everything that's on the screen. TalkBack provides all of this feedback through text-to-speech, as well as vibration feedback and auditory icons. But we also ship another service, BrailleBack, which works in a similar way, but provides feedback on a refreshable Braille display. So this is a device that connects to the Android phone or tablet through Bluetooth and actually changes its state of little actuator pins, so the user can read Braille on the fly. The user can also click on individual cells, which result in click actions being sent to the view that represents the text from that cell, and can also pan through the entire on-screen content to see everything that's on the screen. Most of these Braille devices also include a built-in keyboard, so the user can even enter text. All of these things combined allow the user to drive the phone or tablet from inside their pocket just with this Braille display. A key tenet of accessibility on Jelly Bean and above is the idea of accessibility focus. It works just like system input focus, but it's assigned by an accessibility focus to any view in the interface. So, as a user interacts with the device, the service gets events about the interaction and can decide to assign focus to anywhere in the user interface. Focus is indicated by this yellow highlight you see around the clock widget here. And when something receives focus, the service is intended to speak or provide some sort of feedback to the user. Focus is also the point of interaction for any events or actions that occur from that point forward. So for example, if I double tap while this widget receives focus, the clock widget will receive a click event. If I double tap and hold my finger down, it will receive a long click event, and so forth. So it's up to the accessibility service about how to assign this focus. In TalkBack, we use a heuristic based on whether a view is actionable or not to determine focusability. So what we do is we take a look at the view hierarchy. We see that a view is either clickable or focusable, and we mark that view as a candidate to receive accessibility focus. When we traverse the hierarchy, we take these candidates and we assign focus to them in the order that the user intends through their interaction. And failing to find actionable content, we fall back to actual text content. So if you don't have focusable or clickable content in your application, but you still have text or labeled images, we'll focus those as well. So here's an example of that. What we have here is the folder widget from the home screen that comes default on most stock Android devices. And what we're interested here in is a folder icon. You see the folder icon object outlined in yellow in this hierarchy viewer tree is the current node with accessibility focus. When TalkBack traverses the hierarchy, we see that this view is clickable. So we say, oh, this is an actionable piece of content. We should give it accessibility focus. When the user navigates to this point of the hierarchy, we select this view, search down and traverse its children, and populate speech with the content of its children nodes. So for this example, the image view is labeled with the content description folder, and the bubble text view has the text Google. So TalkBack will speak folder Google. So now let's switch over to a demo, and we'll quickly show how TalkBack will work with your application, how users will use Explore by Touch and linear navigation to move through your user interface. And then we'll do a quick demo of Braille and introduce our new virtual Braille display. So here we have an Android device running the latest version of Jelly Bean. All accessibility on the platform can be enabled through a common location. It lives in Settings, Accessibility, and you can see it lists all the services that are currently installed. Here we have TalkBack and BrailleBack. To enable a service, just tap it and flip its switch to on. You'll receive a warning that it's a privileged service and can do things like retrieve interaction events and get on-screen content. You accept the warning, and the service is now running. As I navigate through the user interface with a single finger, I can actually get feedback for the content that I'm currently touching.
When TalkBack is on, your device provides spoken feedback to help blind and low vision users. For example, it describes what you touch.
So I covered the proximity sensor to silence speech. I can continue to navigate around the interface
When
as well.
talkback is on, switch. 3.5
Let's
G
not stop talkback.
OK, cancel button. Settings.
To activate something in the
When
interface,
talkback is on,
I give it focus,
settings.
and I double tap.
Talkback settings.
That sends a click event to that button, fires the click listener, and opens talkback settings. If I'm unfamiliar with this interface, I can actually navigate it item by item. And here's how I do that. I just do that with a series of swipe gestures.
Talkback settings. Speech. Speech volume. Match media volume.
And so forth. I can move back by swiping in the opposite direction.
Speech.
We also provide quick access to common system functions, like pulling down the notification shade
Notification shade.
or going back.
Talkback settings.
We also have a great tool called the Global Context menu, which allows the user to quickly access common tasks within TalkBack. For example, it's very important sometimes to be able to read all the content on the screen at once.
Touch the screen and explore in a circle to find an item, then lift to select. Read from top. Talkback settings. Speech. Speech volume. Match media volume. Use pitch changes. Speak keyboard feedback and
I'll touch the screen to silence
Speech
it.
volume. Match media.
So you can see that accessibility moved on its own. It would read through the entire user interface and describe to the user what's there. This is a great tool for developers too, because it allows them to open up an activity, enable reading from top, look at each item as it receives accessibility focus, and ensure that the spoken description is accurate for that item. If something's unlabeled, mislabeled, or doesn't receive accessibility focus, it's really easy to tell which widget you need to look into to improve the experience. So in addition to TalkBack, we have BrailleBack. Let's enable
Back.
that.
Settings. Back. Accessibility. Show. BrailleBack. Off. Settings. Off. Switch. Alert use BrailleBack. OK button. Settings.
So now BrailleBack is running, and I've actually enabled in BrailleBack settings, which you can get by clicking the settings button there, a virtual Braille display. So because we don't have a refreshable Braille display connected through Bluetooth right now, it's incredibly useful to be able to see what's on a virtual display, especially for developers. So what we see here is an overlay on the bottom of the screen that actually shows what would appear on a Braille display with its human-readable translation below in actual ASCII text. So this gives you an idea, if you navigate through your interface, what your users will see on the Braille display when they're using your application.
Navigate up. On. Switch.
So you can see that the display updates.
When BrailleBack is on.
Okay,
Alert. Oh.
great. Another great feature of TalkBack is you can turn it off really quickly. You go back into the global context menu and just go to pause feedback.
Pause feedback.
And it's off. Okay. So let's talk briefly about what you as developers need to do to make your applications accessible. All of this content is in our previous year's talk in greater detail, so I encourage you, if you're interested, go back and look at those talks from 2011 and 2012 regarding Android accessibility. You'll get this content in more depth. The first thing to know about accessibility within the native applications is that the widgets that ship with the platform as part of the SDK are all accessible to begin with. A lot of time has gone into instrumenting these for accessibility, and we provide a really great experience for all the built-in widgets. So whenever possible, use built-in widgets within your application. If you do need to create a custom widget, subclass a view that's as deep in the class hierarchy as possible, so you get the benefit of having the accessibility bits in that widget. So there are some widgets that need a little extra care, and these are widgets that are essentially non-text based. In particular, image view and image button. Because there's no textual content to speak or put on a Braille display for a user, it's important that you as the developer provide one. This is done through the Android set content description attribute in your layout, and you'll want to ensure you provide a translatable string for that. If you have a view that's entirely decorative and probably isn't important for accessibility, you can set a content description null. This will do two things. It will fix your lint errors. You'll see your lint warnings because of lack of content descriptions. And it will also indicate to accessibility services that that content probably isn't worth receiving accessibility focus. If you have content that updates throughout the life cycle of your application, for example, a play-pause button that changes state, you can use the view.setContentDescription method to dynamically update the view when its meaning changes. And finally, if you've got one view that is intended to label another and has an appropriate description, you can use the Android label for attribute to indicate to TalkBack or other accessibility services that you're providing a label through another view. If you have a hybrid application or use web content within your application, be sure to use W3C Web Accessibility Initiative standards and guidelines to ensure that the web content is accessible. We do provide access to web content for accessibility services through an injected version of Chromevox. There was a talk on that yesterday, and stop by our sandbox to see a demo. And if you find yourself in a situation where you do have to write an entirely custom widget yourself, there are framework APIs that allow you to do this, but it does require a good bit of extra work. The good news, though, is it can be done. And the better news is we've created a helper class that helps you do that. For purposes of example, we'll use a custom view that we've created. It's BarGraphView. This view is constructed and populated with a title that you see on the top there, and a set of data in an int array where each value in that array represents the value of a bar in the bar graph. So a user can click on bars to highlight them, and we actually draw all of the content from this view with onDraw. There's no internal views that are used. We actually render the text to a canvas, so we're not actually using a text view at all within this application. We also don't really set it focusable or provide any sort of description initially. And for click events, we actually don't use a standard click listener. We listen for touch events and implement our own click listener. So this is basically a perfect storm for accessibility. When you interrogate this view with TalkBack and you move focus to it, it speaks nothing. In fact, it doesn't even receive focus because there's no actual content to speak. This is an example of really the worst case scenario for the accessible user when they try to use your application and there's a view that's just entirely empty. Luckily, we have an answer and an easy way for you as developers to make this widget accessible. So I'll hand it off to Alan, who's going to demonstrate our new helper class.
Thanks, Casey. Hi, I'm Alan Viverette. I'm a software engineer on the accessibility team, and I'll be showing you how you can make your custom views totally accessible, support all of the features in Jelly Bean. But first, who here has written an Android application? Quite a few, awesome. So who here has written custom views for an Android application? Still quite a lot of people. So if you're just using standard widgets, you're off to a really good start. If you're using custom views, you have a little bit more work to do. But first, let's take a step back and think about what's in a view. So we've got our sample bar graph on screen, and visually, it's somewhere on the screen. It's got some dimensions. It has some information that's conveying to the user, here through both graphics and text, and it has an interaction model. So I can click on these bars to change what's displayed. But each of these bars has its own dimensions and positioning. It has its own information that it's conveying to the user. It has its own interaction model. Each bar is individually clickable. And because we're not extending view group and using subviews, we actually have to expose this to accessibility services some other way. So now let's move to accessibility node info, which is how an accessibility service sees the views in your application. Again, you have dimensions and positioning. You have some sort of information that you're conveying to the user. You have some sort of interaction model, clicking, long clicking, scrolling, etc. And most importantly, we have child nodes. So even if your view isn't a view group and doesn't have subviews, you can still expose extra accessibility node infos as children of your top-level view. So that's what we're going to do here. Each bar is going to have an accessibility node info that exposes its information to an accessibility service. How do we do that? There's an accessibility node provider class built into the framework that allows you to create nodes and expose those to the framework. So here we've got, oh, it looks like the sample code doesn't all fit on the screen. Let's shrink that down a bit. Oh, we're not able to fit everything on the screen. It looks like there's a lot of code that's required to use an accessibility node provider. And in fact, there are about 12 more slides of this that I'm not going to go through. Instead, we've made an accessibility helper class called Explore by Touch Helper. This is going to simplify creating and exposing a virtual view hierarchy with just 5 simple abstract methods. This still wraps accessibility node provider compat, which means there's a lot of code on the back end that you won't have to look at, fortunately. This also means that it's going to work out of the box with screen readers, with Braille displays, and with some interfaces that you may have never even seen before, like sip and puff or single switch. Most importantly, this is backwards compatible with API 4. So even if you're targeting Donut, you can still have full Jelly Bean quality accessibility in your application. So how do we start using the Explore by Touch helper class? Well, first we're going to need to delegate handling of certain events, both accessibility events and touch events for when touch exploration is turned on. We're going to need to actually map the touch events from touch exploration to logical items within our view. In this case, they'll be bars. And we're going to need to expose information about these bars to accessibility services. So these are things like positioning and size on screen, actions that are supported, and informational content in the form of a content description. We're also going to need to provide support for user interaction. So a user can click on a bar, and we need to have some way to interact with that, change what's displayed on screen, and let the framework know what's going on. And finally, we're going to test our application. We're going to make sure that the same information that's displayed visually is exposed to accessibility services and can be spoken out loud or displayed on a Braille display. So first, let's move over to the device and take a look at the application with accessibility turned off. All right, we've got our pretty blue graph on the screen. We can touch them, and they turn yellow. We can see that it says BarGraph inaccessible, and for each bar, we can see how high it is compared to the other bars. Let's turn on accessibility.
BarGraph I/O 2013.
And as Casey mentioned, we're just going to use read from top to read everything on the screen.
BarGraph I/. Touch this read from top. BarGraph I/O 2013.
And it's done. So obviously, we're missing some content here. We'd probably like it to read BarGraph inaccessible, and we'd like to get some information out of these bars that are shown on screen. So let's start implementing some support for accessibility using our Touch Helper class. All right, the first thing we need to do, as I mentioned, is delegate accessibility support. So we're first going to create a new BarGraph Touch Helper that extends our Explore by Touch Helper class. We'll go into the implementation details on that in just a moment. But the first thing we're going to do is delegate responsibility for accessibility to this class using viewcompat.setAccessibilityDelegate. We're also going to dispatch hover events first to our Touch Helper class, because when Explore by Touch is turned on, touching the screen is translated into hover events. And we need to handle these hover events specially to let the framework know if we're touching a logical item. So we're delegating in 2 places here. And once we've done that, we can start thinking about the implementation for our class. One thing that we're going to need to worry about is mapping our logical items to something that the framework understands. In this case, the framework is going to use a virtual view ID to reference our logical items. So every view in the framework, every actual view, has a virtual view ID that gets computed. We're going to provide our own virtual view IDs so that when the framework says, could you give me the first child, the second child, the third child, we know what they're talking about. We have to make some guarantees about these virtual view IDs. Namely, that they're one-to-one, which means for every virtual view ID, there is only one logical item that it refers to. And for every logical item, it has only one virtual view ID. We're also going to make sure that they're stable, which means that when we refer to virtual view ID 0, it's always going to revert to the same logical item. We also have to make sure that they're non-negative. There are certain negative virtual view IDs that are used internally by the framework. So we have half of the int range, which is a good amount of virtual view IDs. For our bar graph view, we can actually just reuse the data array indices. So we passed in an int array when we were creating it, and we're displaying these bars on screen in the order that they are in the int array. So our first bar, index 0, is at the very far left. We can go ahead and assign that virtual view ID 0. We can maintain this mapping for all of the array indices in the array because it's one-to-one, it's stable, and because it's an array index, it has to be non-negative. So we'll just map directly virtual view ID index within the array. Now that we have a mapping, we can start to expose some of the on-screen content to accessibility services. So the first thing we're going to do is override getVirtualViewIdAt. This is the first of 5 methods that we'll be overriding in this class. We're going to take an XY coordinate on the screen in view relative coordinates. So 0, 0 is the top left of my bar graph view. And we're going to reuse the same method that we use for hit detection in onTouch event. So you noticed during the demo with accessibility turned off, I could touch a bar and it would change color. That's because I'm overriding onTouch event in my view. I'm taking the XY coordinate, figuring out which bar the user is touching, and changing some of its properties. So we can just reuse this method. It returns an index in the array. Because I'm mapping directly from index to virtual view ID, I just check to see whether I got a valid index. If I did, I return it. If I didn't, I return this special constant, ExploreByTouchHelper.InvalidID. And what this tells the ExploreByTouchHelper class is that the user touched the screen, but they didn't touch any of the logical items within my view, which means most likely the touch will fall to the view itself. If it's not handled by the view itself, it might fall under that. We're also going to override getVisibleVirtualViewIDs, method 2 of 5 that we'll be overriding. And this lets the framework know both the items that are visible on screen through virtual view IDs and the order in which we'd like them to be navigated by swipe navigation. So as long as I populate this 0, 1, 2, 3, 4, as a user swipes right, they'll hit bar 0, bar 1, bar 2, bar 3 in order. If I have something more complicated, say I have 2 rows of bars, and maybe I want to do the first bar, the second bar, the third bar, the fourth bar, as long as I pass those into the array in the same order that I want them to be navigated, that's what the user will see. So now that we have those 2 down, what else do we need to do? Well, once a user touches something, TalkBack is going to speak, BrailleBack is going to display something on the screen. We need to expose information that we convey to the user. So the first thing we need to think about is what type of information. When something is spoken out loud, you have to think about the efficiency and the importance of the items that you're trying to convey. So here, each bar has 2 properties. Its index within the array, where it's displayed on screen, and its value. And we want, when a user touches the screen at random, them to know where they are, what type of item they're touching. So we're going to say bar first. Bar is really short, and so a user, if they're moving around the screen very quickly, isn't going to have to wait very long to know what they're touching. And if they're trying to distinguish between different bars on screen, they'll very quickly hear the index. So we'll speak something like bar 0, value 5. And because we have a highlighted state, we're going to provide a separate content description that says something like bar 0, value 5, highlighted. We've just written a quick helper method here that takes an index within the array, gets the value, checks the highlighted property, and populates the right template, returns a string. We're going to use that string to populate a content description for an accessibility event. So this is the third method that we're overriding, populate event for virtual view ID. Accessibility events are used by the framework to let the accessibility service know what's going on in your application. So for example, when you click on a view, there's a view clicked event. When you scroll, there's a view scrolled event. We're going to populate these with the right content description for the logical item that's sending the event. We also need to expose a little bit more information about nodes. We can expose the content description as we did in the accessibility event. We're also going to expose the user interactions that are supported. And here, you may remember, I was able to tap on a bar to change its properties. So we're going to add a click event, so that if a user double taps on the screen, or if a user clicks on it on their Braille display, it will have the same behavior as if I had tapped it with accessibility turned off. We're also going to set the bounds within the parent view using getBounds for index. Now, this is the same method that we're using in onDraw to figure out where to draw the bar on screen when we fill it with that blue color, and then occasionally we fill it with that yellow highlight. And this is going to ensure consistency with our onDraw, so that exactly where you touch on screen is exactly where our yellow focus highlight will be placed, and exactly where you'll get feedback for a logical item. So you may notice we're reusing methods pretty heavily. And this is why it's so easy to use ExploreByTouchHelper to implement accessibility in your custom view. All right, so now that we've exposed properties about our items, let's take another look at our application and see how it looks with accessibility turned on now. All right, so we'll switch over to our BarGraph Interactive. And when I do read all from top.
Read from top, BarGraph I/O 2013. Bar 0, value -5. Bar 1, value -4. Bar 2, value -2. Bar 3, value 0. Bar 4, value 2. Bar 5, value 4. Bar 6, value 5.
All right, so we're reading out the bar descriptions. That's great. We've got the yellow focus highlight on screen. That's awesome. Let's touch it and make sure that it works correctly.
Bar 5, bar 4, bar 2, bar 1, value -4.
All right, everything seems pretty close, but we're missing one important thing here. That's the title of the bar graph. So we need some way to expose this to the user. We're going to do this. The next thing we're going to do is respond to actions. So we're going to be able to click on a view by double tapping. So when we added our action click in populate node, we need to also handle that later by overriding the perform action for virtual view ID method. Now, we're going to use the same method that we use in onTouch event to actually perform the bar click. So we've got onBar clicked. This is going to invalidate the view so that it's redrawn with the highlight. This is going to change the internal highlight state so that we can draw that bar with a different color. And that's the only action that we need to handle, because that's the only action that we added in populate node. We also need to let the framework know that the action happened successfully. So we're going to invalidate the virtual view ID because we're changing the highlight state. We're changing a property of the virtual view. And we're going to send an event for that virtual view that lets the framework know it performed a click action. So we send event for virtual view ID, which is a method on our touch helper class, with type view clicked. This will provide feedback in the framework, a little haptic feedback, and a little auditory feedback that lets it know and lets the user know that something happened. All right, so now that we have support for user interaction, we'll do one last thing and go back to the device. So we already read through. We noticed that we're missing one thing. Let's make sure that touching
Bar 5, value 4.
and clicking work correctly. So we're good there. And now if we touch the bar again.
Bar 5, value 4 highlighted.
All right, and we hear highlighted. So we're good to go there. We have one thing missing that I mentioned. When we touch the bar graph itself, we should really be reading bar graph interactive. And we might want to provide some additional information to the user just to give them an idea of what's on screen there. So we're going to polish the user experience. We're going to add another string that describes the bar graph view itself. So we're going to populate this string with the title of the bar graph, the type of widget that it is, and the number of bars that are on screen. The ordering here is very important. So when I touch the bar graph, what I really want to know is what is it that I'm touching? It's a bar graph with a title. If I have multiple bar graphs on screen, the most important thing to me is going to be what's shown in that bar graph, what's the title. Second most important thing is the type of widget. It's a bar graph, which lets me know that it's going to contain a couple of subviews and the type of information that I'll be seeing. We're also going to say how many bars are shown. And this is a little extra, and this just tells the user how many things they can expect to touch when they're moving their finger across the screen or swiping left and right. So we have a setTitle method that we've implemented on our BarGraphView. This sets the internal title, which is drawn on screen. This invalidates the view, which redraws the title. And we're going to set the content description based on the bar count by populating this template that we've created with the title and bar count. So now that we've tested and we've ensured that the same information that we can see visually on screen is communicated to an accessibility service, let's go back to the application and do read all from top to make sure that everything makes sense.
Bar graph read from top. Bar graph I/O 2013. Bar graph accessible, showing 7 bars. Bar 0, value -5.
All right, and we just saw this, so I'm going to skip it. But as you can see, my bar graph view, despite not being a view group, not having any views inside of it, is now totally transparently accessible using Jelly Bean APIs. And this runs on Donut. It won't have the same Jelly Bean accessibility, but your application will still compile and run perfectly fine. So just to summarize the Explore by Touch helper class, it looked like it was going to be really difficult to implement custom view accessibility, but it's actually really easy. It's 5 methods that you override, and you're just reusing things that you've already written for the visual aspect of your application. So, to conclude the talk, writing accessible Android applications is actually very easy, especially if you're using built-in Android widgets, adding content descriptions where appropriate, maybe you're associating labels with controls. If you're using custom views, you may want to use the Explore by Touch helper class to simplify things. It's a very easy way to make your application accessible. And if you're using web content, you just follow best practices for web accessibility. Now, if you do all of these things, your application is going to be accessible to more users. Every Android phone has accessibility baked in. If you pull out your phone, you go to Settings, Accessibility, you can turn on TalkBack yourself, and you can try this. If you have a Braille display, or if you don't have a Braille display, you can use the overlay to check Braille back with your application. There are also various other ways of interacting with the device, including sip and puff interfaces and switch access. If it works with TalkBack, if it works with BrailleBack, there's a very good chance that it'll work perfectly with these alternate interfaces. So, Android's built-in accessibility support guarantees that if you have good accessibility, you have a good application, and you have good usability for everyone, you'll have a larger user base, you'll have happier users. So, I hope everybody learned something here today. You can check out the source code from the slides on eyes-free.googlecode.com. We've got demos in the sandbox here on the second floor, and we've got office hours immediately following the talk. We also have plenty of time for questions, so please stand at the microphones in the aisle if you have any questions, and we will answer them. Thanks again. Any questions?
My name is Steve Jacobs, and I really don't have a question. I'm not even a developer, but we have an Android development company. And one thing that wasn't mentioned during the session is the business driver behind accessible design, above and beyond accommodating the access needs of people with disabilities. And you could tell I'm an accessibility advocate. But if you look at our global market and you look at the top 5 highest potential markets, they spell cyber, C-I-B-I-R, China, India, Brazil, Indonesia, and Russia. If you look at the number of people who never learn to read, this can help them. If you look at the number of people who are aging, like me, you're talking 500 million people. 1.5 billion or more people never learn to read. There are English language learners. Being able to highlight text as it's being read using text-to-speech can help them. In addition to people with print disabilities, and we're not just talking about blindness and other vision impairments, but learning disabilities, cognitive disabilities, mobility disabilities, and learning disabilities, which represents about 25% of students in class. 50% of students taking math have difficulty with math. Accompanying learning math with text-to-speech, having images read out, having text highlighted, having math formulas read to you actually strengthens the learning experience. So accessibility is about far more than just accommodating people with disabilities, and I wanted to make sure that that message got out loud and clear during this session. So I hope you don't mind my taking the mic to say that. Thanks.
Thank you for saying that, Steve. And to echo what Steve said, you heard the numbers yesterday, number of devices, you heard the number of app downloads. But more importantly, you heard the number of people in the world who don't yet have access to technology. And as Steve pointed out, as we start touching that segment of the world's population that isn't yet touched by technology, all of these things that we are showing you and that we are showing you in our sandbox are really, really relevant. And in terms of advancing education, in terms of advancing access to technology, in terms of bettering people's lives, the impact you have is huge. And as Alan pointed out, it's very, very easy to do. And that's what is so wonderful about the opportunity we all have together.
Yes.
Yeah. So, is this working?
Yes.
Yes,
Yep.
yes.
Yeah. My name is Gaurang, and I got a question. Is it possible to switch on the accessibility features without necessarily switching on TalkBack? Or rather, is it possible to programmatically switch on TalkBack within the app?
So let's see. It is possible to use the accessibility features without TalkBack. If you have an accessibility service that is not TalkBack, for example, BrailleBack, it is not currently possible to turn off speech output, but you can always mute your phone if you don't want it talking while you have TalkBack turned on. As we showed during the talk, you can turn on, you can pause TalkBack. Actually, let's switch back to the device real quick. So you can pause TalkBack by doing the down right and
Pause feedback.
pausing feedback, at which point TalkBack is basically turned off. You can turn it back on really quick. This is great if you're a developer and you just need to do quick testing, switch back to having accessibility off to figure out what's wrong, go back. Does that answer your question? Or?
Well, actually, what I was asking is if I want, say, TalkBack-like features, but I don't want my users to switch on TalkBack all the time.
I see.
And
Yeah, that's a great candidate for writing an accessibility service. If you want some of the features, maybe the ability to read notifications out loud
Yeah,
as they're received.
yeah.
And we've seen a lot of great applications that rely on the accessibility framework. I should mention TalkBack is totally open source. So if you have any questions about how something is implemented in an accessibility service, you can check that out again at eyes-free.googlecode.com.
BrailleBack as well.
And BrailleBack as well is open source.
And yeah, so to quick round off that question, those of you who are familiar with the accessibility stack probably already realize this. So Android accessibility is layered. The framework has accessibility APIs. It provides things like accessibility actions, all of which are covered in previous talks. And then you write an accessibility service that leverages these. TalkBack is the one that exercises pretty much every corner of that API and those services. But there's nothing sacrosanct about TalkBack as the only accessibility service. In fact, you actually have to turn TalkBack on for it to be active through the accessibility settings. So as Alan said, you can write TalkBack Lite, you can write TalkBack Deluxe, you can write TalkBack Lite, you know, whatever, and get the experience you want. And that's how the framework is created. So an accessibility service has three aspects to it. One is querying what's on the display, what's in the view hierarchy, and getting a full handle on the user interface. The other is providing feedback to the user using whatever modality they are using, be that speech, be that braille. And the third is translating the user's intent, such as button presses or whatever, into actions that the system executes, which is what, say, a one-button interface would leverage. So for instance, if you're building a one-button interface, for someone who can see perfectly well, you wouldn't actually leverage the speech output capabilities or the braille output capabilities. You basically have your one-button interface control the device.
Right. Thank you so much.
And one additional point, Casey probably demoed this during his, but didn't say it out explicitly. Because of the separation, on Android, you can actually run TalkBack and screen magnification simultaneously. So you have a low vision user who both wants to see the screen because he can see some and wants speech output, basically doesn't have to make a choice saying now I get speech or now I get magnification. And the reason why we are able to do these kinds of combinations is because of this layered architecture.
If you'd like to see a more in-depth demo of screen magnification, please feel free to drop by the accessibility sandbox.
Your question, please.
My name is Tang Chen, and I have a question. Can Google Play help the brand man to find apps that has good accessibility easily?
That's a really good request, and we will take that back. We've heard that many times in the past. Today, what we see users doing is primarily wisdom of the crowds, which has worked well. But I agree with you that it would be really nice to be able to find apps based on the user's needs, not just for the blind user. For instance, an app that works very well for a low vision user may not necessarily work that well for a blind user. And it would be nice for users over time to be able to say, these are the types of things I'm interested in terms of user capabilities and find apps that you like. So that's definitely a request we'll take back to the Play team.
Okay, thank you.
All right, if that's all the questions, we'll be at the Accessibility Sandbox outside. Again, thank you everyone for coming.
Thank you for coming,
Thanks.
everyone.